This is Chapter 7, Section 3. So this is more multiplication properties of exponents. Last section you were looking at multiplication when you had the same base, and when you were multiplying them. And now we're looking at what if you have a power to a power, or a product to a power. And so we're going to look at those two things. So first off, here's the example that we're going to start with is if you had x to the fifth and raised it to the second power. Last section you were looking at things like this, x to the fifth times x squared, and you would add the two, you would get x to the seventh, right? Well, now we're looking at, you have x to the fifth raised to the second power. So if you have something raised to the second power, it means you have that twice and you multiply them. So you have x to the fifth times x to the fifth. If we use the rules from last section, when you have same base and a power multiplied by each other, you add them. And so that would be x to the 5 plus 5. Or 5 plus 5 can also be written as 5 times 2, which is 10. So if you see this and you think about it turns into this, what actually happens is you're just multiplying these two numbers. And that leads us to the rule. If you have some base raised to the m power raised to the n power, the answer is a raised to the m times n power, as long as a is not 0 and m and n are both rational numbers. So here are a few examples. 4 to the second power, and just take 4 times 2 is 8. 3 times 5. Fractions, it works the same. So you take 3 halves times 3, you get 9 halves. 1 half times 3 fifths. Remember, you're just multiplying across. 1 times 3 is 3. 2 times 5 is 10. 3 tenths. Okay? So the way this works, n to the fourth raised to the seventh power would just be 4 times 7, or n to the 28th power. X to the 2/3 to the 1/2, we're just multiplying across. So that's x to the 2 over 3 times 2 is 6. And we want to reduce that. And that turns into be x to the 1/3 power. All right, go ahead, pause your video, and try a few of these on your own. First one, A, would be p to the 20th. Second one, part B, 4 times 5 is also the 20th. C, oops. One half times 1/4 is going to be p to the 1/8. And the same with D. P to the 1/8. Okay? Hopefully my pen is going to work for me. Now, what if we have, so we have a power, y to raised to a power times y raised to another power, which is also raised to a power. So an exponent raised to an exponent. And we have to simplify this. So how does that work? Well, what we want to do is think order operations. We do the power first. So we're just going to leave y to the third as is. And we're going to take y to the 5 halves times -2. So y to the 5 halves times -2. That would turn into, I'm going to replace this down here, 5 to the -2nd, or 5 times -2 would be -10. So y to the -10 over 2, which turns into y to the negative fifth. And then using last section's rule, we would add these, so that would become y to the negative 2. Sorry about this. And if you also think back, y to the negative 2, let's see if we can get that. Y to the negative 2, remember you can't have a negative exponent, and that's when you take the reciprocal, so that becomes y, 1 over y squared. Okay, go ahead, try some of these on your own. First one, we're going to leave x squared. This is going to be x to the negative 24th. I apologize for my pen. X squared times x to the negative 24th. This becomes x to the negative 22nd. And that becomes 1 over x to the 22nd. Okay. Here we do the power again first. So we have w to the negative 2 times w. This becomes 5 times 3 is 15. 15 over 3. 15 over 3 is just 5. Add these two and you get w to the third. Here, it's first, so the power raised to the power is first. So we're going to take negative 5 times negative 1/2. So negative 5 times negative 1/2 becomes s to the positive 5 halves times s to the 3 halves. Let's see if this pen will work for me. Add 5 halves plus 3 halves, you get s to the 8 halves. And 8 halves you find out is s to the 4th. Okay? Now, if there, whatever, remember, anytime you have something in parentheses raised to a power, everything in the parentheses is raised to that power. So, what that means is 4 times m to the 1/2 to the third power actually means that there are 3 of these. 4 times m to the 1/2 power times 4 times m to the 1/2 times 4 times m to the 1/2. If we split these up, it actually means that there are 4 times 4 times 4. There are 3 4s. Count them 1, 2, 3. And what that actually means is that it was just 4 to the third in the original. So it's almost like, you could say this 3 almost gets foiled out. It's not a foil, but it's similar to that. So it's 4 to the third, and then also this m to the 1/2 is to the third power. So what's m to the 1/2 to the third power? Well, we multiply these. 3 times 1/2 is 3 halves. And now you just simplify. 4 to the third is 64. M to the 3 halves stays as is, and that's your final answer. So this is how it's written. If you have a times b in parentheses, and this, even if you had a third term, okay, the n power exponent goes to each one of those bases. And here's some examples of that. Okay. So which expression would represent the area of the square? So how do you find the area of a square? You take the side times the side, or the side squared, right? So basically what we're saying is we are taking 5 times x to the third squared. Okay? We're taking this length and squaring it. So that means we have 5 squared times x to the third squared. 5 squared is 25. X to the third, we multiply these. So that's x to the 6th. Right there, D. Pause your video and go ahead and try these. These will be the last ones we do. Okay. Part A, we have 7 to the third and times m to the 9th to the third. 7 to the third equals 343. M to the 9th to the third, you multiply them, is m to the 27th. Here, we got 2 to the negative 4th times z to the negative 4th. Since they're negatives, they can both get flipped the reciprocal. So we actually have 1 over 2 to the 4th times z to the 4th. Well, 2 to the 4th is just 16. So we have 1 over 16 times z to the 4th. And then last one, if it's going to let me do it. So we've got 3 to the negative 2. I don't think it's gonna. And let's try this one more time. G to the 4th to the negative 2. Sorry, it doesn't want me. Anyway, what happens is okay, let me see if I can just get straight to the answer. So the 3 to the negative 2 is going to flip, right? So you're going to have 1 over 3 to the 2. 3 to the second power, which is 1 over 9. Okay. The g to the 4th to this negative second power is going to become, when you multiply them, g to the negative 8. So that means those are going to flip as well. So you're going to have 1 now let me do it. You're going to have 1 over 9 times g to the 8th power. And that will be how that last one ends up. Sorry about my technical difficulties, but that is the gist of this section. So if you know how to do those rules, you will be just fine.